Okay, so in between all these here, we can see that only a few bubbles were being formed. So that is going to be the least reactive. And on Z, we had the most bubble formed and there's no metal left. So Z is going to be the most reactive. That leaves us W and Y to sort out. Both had bubbles forming quickly. W has got some metal remaining. Y says all the metal had reacted, so Y is more reactive than W, and therefore we get that structure. Carrying on, here we're told that the experiment was repeated with sulfuric acid instead. Metal Y reacts and bubbles form quickly, and then the metal reaction stops. Most of the solid metal remains. Explain why the reaction between Y and Z stopped even though there's some metal left. So what happens here is that the metal sulfate that's formed is formed and coats the unreacted metal, and this prevents the metal reacting further. So I've given an example here of a weak acid, and you can see the weak acid has this symbol in the middle, and this means that the reaction is reversible, which means it only partially dissociates. So what we need to say here is it partially dissociates, partially turns into ions, which in this case means that there are going to be fewer H plus ions than expected. Okay, in this question, we need to calculate the total number of atoms, and we're given a mass over here. Let's use a different colour here. We're given a mass over here. So what I need to do, first of all, is get that mass converted into moles. So my first job is work out the moles that are involved here. And according to that top triangle, the moles is going to be the mass divided by the MR. So the mass is 5.13. The MR, we're going to have to work it out for this because they haven't given us it as a whole, so let's do that. So 2 lots of aluminium is 2 times 27. I've got 3 lots of sulfur, which is 3 times 32. And be careful, I've got 4 times 3, which is 12 lots of oxygen, which is 12 times 16. So 12 times 16 is 192. That one is 96, and that is 54. Add those together, so plus 96 plus 54 is going to be 342. Let's pop that underneath there, 342. Put that into your calculator, and you get an answer of 0.015 moles. Okay. Second step, what I want to do now is convert that moles into particles. So we use the second triangle to work out the particles is moles times Avogadros. So here we've got number of atoms equals moles times AC, moles times AC. Now we need to be careful here because the moles are 0.015 and Avogadro's constant is there, so it's 6.02 times 10 to the power of 23. But we also need to know that in this aluminium sulfate, we need to count how many atoms there are going to be. So in aluminium there's 2, sulfur there's 3, because we've got to times it by 3, and oxygen is 12. So it actually gives me, because you add those together, 17. So I'm going to times this also by 17. So let's do 0.15 times Avogadro's constant, and then times the whole thing by 17, and I'm getting an answer here of 1.5, and I'm going to call that 1.54 times by 10 to the power of 23. Marks wise, to give you a mark obviously for the answer, you're going to get a mark for working out the 342, and then a mark for working out the moles, and then a mark for doing this step of the equation as well. Okay, this question here, there's different ways to get to this question. I'm going to show you one method, and I'll explain a second method that if you wanted to do that way you can as well. But basically we've got two equations, and they want to know which equation is right based on the fact that we're going to get 4.48 and 24.84 grams of these chemicals. So the first thing I'm going to do is I'm going to work out the moles of Fe in this 4.48. So the moles, according to my triangle, is mass divided by the MR. The mass is 4.48 and the MR for iron is 56. So if I do that, 4.48 divided by 56, I'm getting an answer here of 0.08 moles. Do the same for the lead. So I've got moles of Pb is going to be the mass divided by the MR. The mass this time is 24.84. The MR is 207 because it tells me that here. So 24.84 divided by 207 is going to be 0.12. Okay, what I'm now going to do is take these two numbers and I'm going to divide by the smallest number. So I've got 0.08 and I've got 0.12. I'm going to divide them both by 0.08. So that gives me 1 and that gives me 1.5. I can't have 1.5 of an atom. So what I'm going to do is double that line to get a whole number, and that gives me 2 to 3. So my ratio of iron to Pb must be 2 to 3. So if I now go up to my two equations, in this equation the ratio of iron is 1 to lead 1, so it's not that one. In this equation the ratio is 2 to 3, so it is going to be that one is the right answer. So I would then just say at the end the answer is going to be equation 2. Okay, marks wise, you're going to get a mark for doing this final step here, a mark for working that, and a mark for doing that to get your answer. I said I'd give you a different way of doing it. What you could do is just take that amount and then calculate the amount of Pb by reaction 1 and then reaction 2. Do that using reactive mass calculations. It takes a little bit longer, but it'll get the same answer if you're more confident that way.